Once again, welcome to my YouTube channel. And in line with what we have understood previously in this example 8 part A, we have heard that if we can identify a function that is written in this format, a derivative over its function, then you take it ln, assume this one must be coming from the natural logarithm of fx, ln fx, differentiate it to check whether it works, and of course adjust in a constant. That is what we've understood, and part A has worked in very well for us. So let's go to example 8 part B. And you're supposed, in this part, you're supposed to integrate the cosine of x all over 3 plus 2 sine x. And it goes without saying that the numerator is the cosine of x, and we happen to have the sine of x at the denominator. So therefore, this is a derivative of this, and therefore we let y be natural logarithm of 3 plus 2 sine x. That is exactly what it is. If this is a derivative of this, then we generally run to ln the denominator. So dy dx becomes, the dy dx of the denominator is always going to be 1 over, because we are dealing with ln, 3 plus 2 sine x, 3 plus 2 sine x times, now the chain rule comes in handy here, 2 cosine x, and the final submission is 2 cosine x, or 3 plus 2 sine x. So if you compare this with okay, we have heard that we are comparing 2 cosine x 3 plus 2 sine x versus what we may have expected, or what we were anticipating, the cosine of x over 3 plus 2, the sine of x. This is a derivative, and we wanted to integrate a derivative to give us a function. That is exactly what we wanted. Yes, we have been able to suggest the function is this one, or the function is going to be ln 3 plus 2 sine x. But to verify this, we needed to differentiate this to give us a gradient, and if it agrees with this, then we take this to be our integral. After differentiating what we suspected, we have gotten 2 cosine x, or 3 plus 2 sine x, which is twice more, which is twice what we wanted. And therefore, if this is what we suggested to be our function, and it is giving us twice than we wanted, twice what we wanted, then we must get back to the function and divide it by 2, so that it will give us the exact result which we needed. What we suspected is going to be our function is giving us twice what we want. So our function must have been divided by 2 to give us exactly what we want. So the integral of the cosine of x over 3 plus 2 sine x is a half ln 3 plus 2 sine x plus a constant. If you integrate this, yes, it will take us here, and this one now multiplied by a half, of course it will give us here, to give us this. And that is just like what we need to understand. Again, very, very important. And let me just highlight it once more. Very, very important. using try if you have something, a function that can be written that way. There is a derivative divided by a function, then try ln fx and differentiate to check and adjust in a constant. That is very important for all of us. And I hope that has sunk in our minds, and we will find it very useful even when we try to solve future questions in this topic. All right.